galvanic cell. In galvanic cell, you can see two tubs. One tub is a zinc in a zinc solution. Tub B, copper in copper iron solution. So that means you have zinc solid with the zinc iron solution, copper with the iron in solution. In the mid, I put a salt bridge. The use of salt bridge is to balancing out the iron, to balance out the iron. Now, if I connect it through a wire, These two separate tubs, electron will start to flow. And this electron will flow, will generate electricity called the EMF, electric energy. So electron flowing. Now let's look onto the top. What happened? The zinc will dissolve. The zinc solid will slowly dissolve it into the iron. And the copper ion will slowly depositing onto the copper solid. If you look onto these two reactions, metal displacement and a galvanic cell, you can see some similarity. The top one, zinc dissolve, copper deposit. Zinc dissolve, copper deposit. Look at bottom. Zinc dissolve, copper deposit. So look like they are the same reaction. Yes, they are same reaction. We look onto the standard reduction potential table onto the top. How do we do it? Remember the rule? Oxidation, reverse arrow. Zinc from solid become aqueous. Copper from aqueous becomes solid. Reduction. So we can put it onto the top. Now look at the bottom. How about the zinc and copper? You will find they're using exactly the same rule. So you can use the same rule to do the standard reduction, to do the galvanic cell, to get the standard reduction potential. Here, two more things you need to highlight. First, the electron flow from zinc to copper. So now we focus on electron flow. How does it represent on the galvanic cell? From zinc to copper. You put this arrow. Now, that is two separate tubs. One part is oxidation. The other part in reduction. How did you determine? Oxidation is called anode. Reduction is called cathode. Students may struggle to memorize. How can I remember anodes? They draw an ox. So N always is an oxidation. So an ox. Cathode, red cat. Imagine if you see an ox meet a red color cat. who will chasing who? Will a cat chase the ox or the ox chase the cat? The answer must be the ox will chase the cat. The ox will chasing the cat. So, once you determine oxidation reduction, you just write anode on the oxidation, cathode on the top of reduction. And that's all. Now let's do some exercise. First one, highlight. Put the arrow. Which flow to which? Must be from top to bottom, otherwise it won't flow. So must be magnesium flow to iron. Magnesium oxidation, iron reduction. Electron flowing this way, from anode to cathode, and ox chasing a cat. Do another one. PB zinc, highlight on standard reduction table. Which flow to which? Top flow to bottom. So, zinc is oxidized, lead reduced, as follow. Careful, this is the other way around now. Zinc is oxidized, lead is reduced. So the electron flowing this way. So don't say left to right, no such left-right rule. It's based on the potential, the high flow to the low. No such left-right rule. Next. Nickel flow to copper. Oxidation. Reduction. Which flow to which? Nickel flow to copper. On this table, I hope students will understand. You will have to determine two things: which electron should flow, which side is oxidation, and which side is reduction. Oxidation is called anode, reduction is called cathode.